going to go over exam number 10. On February 12 and February 14th, February 12 Wednesday, I'm going to give you exam. I'm going to give you a quiz which is going to be based on exam 10. And February 14th, I'm going to give you exam 11, which is going to be based on exam 10. I'm just going to add 3 new problems. Okay, so let's go over exam number 10. Exam 10 set 1. Set 1 and set 2 are the same, but set 1, let's first go over set 1, then I'm going to go over set 2. What about, okay, yeah, that's it. So 1, 2, 3, 4, 5, 6, 7, and 8. This is the multiple choice form. So let's first go over multiple choice form. So 4 kilogram, right? 4 kilogram wood on wood. So this is problem number 1. First find the weight. Weight is of course 4 times 9.8 is 39.2. So normal force has to be 39.2 as well. Force applied is 56 Newton. FF is, by the way, FS is less than FA. Why? Because mu s Fn is less than 56. So FF is mu k Fn. So 0.3 Fn is 39.2. So this is 11.39.2 times 0.3, 11.76. So F net is equal to Fa minus FF. FF is 11.76. So F net is 56 minus 11.76. F net is, I believe, 48. All right. So problem 1 is for I believe this is 44. 56 minus 11.76 is 44. All right, Newton. Okay, so now problem number 2. So that is that would be 1, 2, 3, 4, 5. So this is 5. Okay, now let's go over problem 2. Problem 2, you have mass 1 is mass is, I'm never going to remember this mass. 0.144. Velocity initial is 38. Velocity final is negative 38. And at the time, 0.8 millisecond, which is 0.0008 second. What we need to find is momentum initial is equal to m1 v1 0.144. v1 is 38. So 0.144 times 38, 5.472. Momentum final is equal to m1 v final 0.144 minus 38 minus 5.472. So impulse is momentum final minus momentum initial. So minus momentum final is minus 5.472 minus 5.472 times 2 is about 11 minus 10.944. So impulse is force times impulse is, what is impulse? Impulse is force. The force, the time it takes for the force to act on an object. That's what impulse is. So the force is impulse over t. Impulse is negative 10.944. This is point 0.0008, and that divided by 0.0008, and that is 13680. 13680 should be 13680 is 4. So number 2 is 4. All right, so let's go over number 3. Number 3 is all right. m1 v1 m1 v1 plus m2 v2 is equal to m1 v1 plus m2 v2. Momentum initial is equal to momentum final. So what is m1, what is v1, what is m2, what is v2? Okay, so m1 is 0.355 and v1 is 0.095. I forgot my glass, I cannot even see. 0.710 and v2 is 0.045. Okay, this is before and this is after mass 1, but velocity 1 is 0.035. All you need to do is put this thing on the calculator. 0.355 times 0.095 plus 0.710, 0.045 is equal to 0.355 times 0.035 times 7 and 8. Okay. Plus m2 is 0.710 v2 prime. So 0.355 times 0.095, and that is 0.033725 plus 0.710 times 0.045, and that is 0.03195. 0.355 times 0.035, 0.012425 plus 0.710 v2 prime. Okay, so this plus this minus that, 0.03375 minus 0.03195 minus 0.012425 divided by 0.710, 0.015. So what is the answer? The answer is okay, so let's do it again. 0.03375 plus 0.03195 minus 0.012425 divided by 0.710, 0.075. Okay, so this is lots of points. 0.075. v2 prime is 0.075 meter per second, and that must be what? That must be 4. Problem 3 is 4. Okay, number 4 is Josh. Josh jump height is 0.7. Josh crouch height is 0.3. So VF square is equal to VI square plus 280. So this is 0. VI square plus 2 times 9.8 negative 0.7, because at 0.7 the velocity is 0. So V is equal to square root of 2 times 9.8 times 0.7. I believe this is 4. Square root of 2 times 9.8 times 0.7. That's 3.7. So 3.7 is square. 3.7 is square is equal to 0 plus 2a is 0.3. So 3.7 is square over acceleration. Acceleration is 0.6 is acceleration. So this is probably 22. This is square divided by 0.6. That is 22.86. 22.86. So 22.86, that has to be number 3. Number 4, number 3. Okay, number 5. So it is number 5. Okay, the electric lift. So this is the easiest one. Your power is equal to F velocity. So power is equal to ma, well, F velocity is distance over time. So I think P is given. P is 1, 2, 1, 2, 3. Distance is 9 and time is 15. 9 divided by 15 I think is 0.6. 9 divided by 15 is 0.6. So power is 12, 1, 2, 3, 12,000 divided by point, or time multiplied by 0.6. So times 12,000, and that is 7200 watt. 7200 watt must be number 5, 4. Number 6 is gonna be the combined. Okay, so number 6 is centripetal acceleration. You have this is radius is probably 16. Is that right? Yeah, radius is 16, and the car is 100 kilogram, and the time is 10 seconds. So centripetal acceleration is pretty easy. So velocity is distance versus time. Distance is 2 pi r. Over time is 10 seconds. So velocity is 2, 3.14 divided by 16 times 10. All right, so 2 times 3.14 times 16 divided by 10. Velocity is 10.048. So acceleration is v square over r. So square 100.96 divided by 16, 6.31. So 6.31 is the acceleration for problem number 6. Problem number 6, 6.31, and that is 1. So we're going to do problem 7. Problem 7 is the hockey. All right, hockey puck is initial velocity is 20 meter per second. All right, so initial velocity is 20 meter per second. Final velocity is 0. Okay, because of friction make it stop, and the distance is 0, and the final distance is 120 meters. All right, so we know that the work done by kinetic energy, okay, kinetic energy rise to velocity. Work done by kinetic energy at location 1 is equal to work done by friction at location 2. So friction really kind of suck off all the kinetic energy from 0 meter to 120 meter. That's the story over here. So the kinetic energy is half mv squared is equal to ff, work done by friction, ff d cosine theta. So half mv squared is equal to ff is mu mg, right? Okay, because fn is equal to mg at the y direction. Okay, d cosine theta. Okay, so half mv squared is equal to mm cancel. So v squared is equal to 2 mu g. G is I'll write half v squared is equal to mu g is negative 9.8. d is 120, and this is negative 180 degree, so it's negative 1. So half v squared is equal to 100 times 120 times 120 times 9.8, 1176. 176 times 2 times 2, and that is 2352. 2352, right? 2352 mu. All right. mu. Okay, good. So v squared is of course 400. 400 is 2352 mu. So mu is equal to 400 2352. 400 divided by 2352, and that is mu is 0.170. 0.170, that's problem number 7. 0.170 is 2. Problem number 7 is 2. Now problem number 8. Problem number 8, I give you 20 meter per second at 30-degree angle, right? What I ask you to find is the range, the height, and then the time. Okay, so the range is d is equal to vixt, and the height is vf squared is equal to vi squared plus 2ad, and the time is d is equal to vat plus half at squared, and then vf is equal to vi plus at. So pretty easy. So 20 cosine theta and 20 sine theta. So this is 10 and this is probably 7.3. 20 cosine 30. Oh, 17.3? Oh, sure. 17.3. Okay. All right. So d is equal to 17.3 times t. This is 0, and this is of course 10 square plus 2 times negative 10 d. So d is equal to 100 divided by 20. So d is equal to 5. We found this one already. Ground to ground, 10t minus 5t squared. So factor out 5t. So you're gonna get 5 minus t. 2 minus t. 5 goes to 10, 2 minus t. So t is 2. So vf is equal to this is vi. Again, vi is t is 2. Oh, we found the t. We don't have to do anything. All right. So d is equal to 17.32. 17.3 times 2, and that is 34.6. 34.6. All right, so now we have a range, height, and time. 34.6, 5, and 2. Okay, so now there is only one way you can, only one answer, and that is A. All right, now we're going to do short response. Short response number 10 is number 9 is pretty easy. Number 9, I gave you incline. Wood on wood. Wood on wood. So this is your FF. This is your FG parallel. You know that F is equal to MA. Of course, F hat. So FG parallel minus FF is equal to MA. FG parallel MG sine theta minus FF is mu MG cosine theta is equal to MA. M cancel. G is 9.8 sine 30 minus mu is 0.3 for wood, 9.8 cosine 30 is equal to A. This is 4.9 minus 2.5 is equal to 2.4. So acceleration is 2.4. That's number 9. Number 10. So number 10, to take a look what number 10 is. Number 10 is okay, M1 is 6. Okay, so M1 is 6 kilogram, M2 is 10 kilogram. So in this 10 kilogram, 8 plus 2, 2 is alien. Okay, so this moving down 4 meter. All right, so that means it's accelerating to the south. What does that mean? You're gonna feel heavier. Oh no, you're gonna feel lighter. Why is that? Because Fn is gonna be less than Fg. How less? Fn is gonna be mg minus a. Fg is mg. So this one is bigger than that one. Okay, so let's do it. You're gonna feel lighter. Okay, how? Acceleration is m, no, g m minus m plus m. So it's 10. You have 10 minus 6 over 16. So 440 over 16. Okay, good. Now 40 over 16 is something, I guess. 40 divided by 16, 2.5. 2.5. Okay, now we're gonna see mg is mg, so 2 times 9.8, so 19.6, or just use 10. All right, so 20. So his weight is 20 Newton, but his apparent weight is Fn is mg minus a. So m is how much? 2. G is 10 minus 2.5. So 2 times 7.5. So 15. All right. So yeah, apparent. So we're gonna feel lighter for this reason. Number 11. Someone finished the test in 10 minutes today. That was amazing. Number 11. I solved this problem in the class. So you have Hooke's law over here. Okay. All right. So this is before. This is after. All right. So a bullet is held against by a spring, which is compressed 5 centimeter. The spring is equilibrium because bullet is outside. So all the kinetic energy, all the potential energy stored in this spring become the kinetic energy, which led to the velocity of the bullet, which we are trying to find. K is probably, I gave you 200 Newton meter. I gave you the mass of the bullet is 0.1 kilograms. All right, so PE is equal to KE. So KE is half mv squared and PE is half kx squared. This cancel. So velocity squared is kx squared over m. 200 times 0.05 divided by 0.1. I believe this is 5. 200 times 0.5, 0.05 square times 200 divided by 0.1, 5, the square root of 5, the square root of 5 is 2.24. Velocity is 2.24. And that is problem number 11. Problem number 12, you've seen it many times and you made many mistakes. Not sure why. Problem 12 is pretty easy. You can do it using calculator in a fraction of a second. 1, 2, 3, 4. 1, 2, 3, 4 second. 1 meter, 2 meter, 3 meter, 4 meter. 1, 2, 3, 4. The car moves for 1 second with constant velocity, 1 meter per second, and then it remain at rest, and then it moves with constant velocity, constant acceleration, and comes back to right there. Okay, so convert this one to velocity versus time graph very quickly. Okay, so past 1 second, the velocity is 1 meter per second. The 1 to 2 second velocity is 0. 2 to 3 second, at 3 second, velocity is 0. Okay, at 2 second there is a big velocity, and this velocity is equal to this velocity. Okay, so what is this velocity? Okay, area is half of bh. Area is displacement, so 4 minus 1 is 3, 3 minus 2 is 1, so it's 6. So this is negative 6. So this is 1, 2, 3, 4. This is 2, 6. this is 4 comma negative 6. So y is equal to mx plus b. Before that, we can say this is x1, this is y1, this is x2, this is y2. y2 minus y1, x2 minus x1, minus 6 is equal to 4 minus 2, so minus 6, which is acceleration. So then you can directly find 6 is equal to m minus 6, 2 plus b. So b is 18. So vf is equal to pi plus 80. So vf is equal to vi is 18 minus 6t. So vf at this one, how much I gave you? 2.2 second. So 18 minus 6, 2.2. 6 times 2.2, 13.2. 18 minus 13.2. So 18 minus 13.2, 4.8. Velocity at 2.2 is equal to 4.8. Power is equal to FV. So power is equal to MAV. 10. Acceleration negative 6. 4.8. So 4.8 times 6 times 10. 288. Power is negative 288 watt. Okay, and that's gonna take us to problem number 13. So problem 13 would be the same. Well, problem 13 is you move something to the north, how much? 12 meters to the north, and this is south, this is east, this is x-axis. You move 32 degree, you move 25 meter at 32 degree southeast. 90 minus 32, 58. So this is 58. If this is 58, this would be parallelogram. 180 minus 58, 122. This is 58. This is 122. So if you add them, that's going to be 360, but we don't need that. We need parallelogram. This is, we need the angle between two vectors. That's all we need. That's all we need, angle between two vectors. So r square is equal to a square plus b square plus 2ab cosine theta. A is what? 12 square. B is 25 square plus 2, 12, 25 cosine 122. You can directly type it in the calculator. 12 square plus 25 square plus 2 times 12 times 25 cosine 122, and that's 21.23, 21.23, and that is problem number 13. Problem 14, you're just going to double it. Problem 14, you can do two-way. Mass 1, mass 2, distance is v, and Fg is calculated. It is 10 Newton. So you can write Fg is mg m1 m2 over r squared as 1d, right? Okay, so you can write 1, so r squared. So then Fg is equal to g m1 m2 over 1d, right? 1d squared. So Fg is equal to g m1 m2 over d squared, right? And how much is that? That is 10 Newton. So now, secondly, Fg is equal to g m1 m2 over, you're going to double it. So 1 become 2, this 1 going to become 2, 2d squared. So the add G, M1, M2 over 4B squared. So what is this one? This one is 10. So FG is equal to 1 over 4, 10, 2.5. You don't have to do anything else. You can do 1 over R squared. So R is what? Double. So 2 squared. So 1 over 4 times 10. So 2.5. You can do this way or you can do that way. It's up to you. I think that's the test. Okay. So set 2, I'm not going to do it. I'm very tired. Set 1 is actually set 2. If you don't understand anything from set 2, come ask me on Monday. But pretty much this is, I just changes the digit. Set 2 is really easier than set 1. I'm going to post it on the Google Classroom right now. Please set 2 people. Understand, I'm a little bit tired. Otherwise, I have planned to do set 2 as well. And if you have any question from set 2, ask me on Monday.